Hello all. So it's a continuation video of the transfer function of an AC servo motor. Okay, so please be aware of that one. In this video, maybe I will try to complete it within 5 to 7 minutes, or otherwise it may cut to connected to two videos. Okay, because it is having a very lengthy equations and everything will be there. So please be concentrate on listening to this one. Okay, in this video, we'll only discuss about the transfer function of an AC servo motor. So, who don't you need to recap this one. So please understand this very well. Okay. And then the next one is so equation, electrical equation, we and also mechanical equations. Everything we need to discuss in separately, and also there are some equations with respect to voltage, with respect to speed, with respect to torque also. So everything we need to be discussed in step separately, and after that we need to combine each and everything. Like how that in the DC motor, DC servo motor, we first made the electrical equations, after that the mechanical equations, and after that we combined. After we took the complete transfer function. In the same way, we are also doing this one. So as in the previous one, in the ABC to DQ axis is there, right? So that DQ is how exactly it will be there. So if you see here, this is the A axis and C axis and the B axis, which is having 120 degrees of the part will be there. And alpha beta, it is having a combination of the a little bit of in between the two things will be there. That means a three coordinate system is converted into two coordinate system. That we call it as a alpha and beta. That is one is a beta and one is alpha. Alpha is always will be aligned into the A axis. That means it will be 0, and the beta will be a 90 degrees of phase shift will be there. So that will be in this way. So alpha beta DQ. So ABC to alpha, and the alpha beta will be converted to again into DQ, which is having a common. This is a what we'll call it. It is a summation equation will be there. If you see here, it is the D equation. Okay, D axis, and in the same way here also we are having a Q axis will be there. So these are how they are coming is by the AB alpha beta to DQ, alpha beta to DQ equations, and DQ to ABC equations, ABC to alpha. So A, B, C to alpha. So by this equation, if we are representing in the this graphical form, then we can get the same graph like this itself. Okay. So here now we are going to discuss about the D voltage equation, because the voltage equations will be very important, because all everything runs with the KVL, right? So always will be KVL, Kirchhoff laws, right? So VD, that means D axis, so that's why I'm taking as a VD, and R into ID plus L into di by dt. Here ID, okay, that means I and the D component. So I can't able to write this one, so that's why I wrote it like this. Okay, and the same way IQ also minus WL IQ. That means it is the angular component which is having some things will be there in the D axis also. In the same way, Q axis equation, how it will be there means VQ R into IQ L into DIQ by dt plus WL d by dt. Here an extra component will be placing there, that is called a displacement factor, that we will see here. In this equation we are having these equations describe the current dynamics. That means if you see here how the current is moving, that means the D axis current, how it will be affecting the voltage, and also a Q axis current, how it is affecting the Q axis voltage, that we will discussing here. Okay, in the same way the torque equation also very much important. As I already said, electrical equation which is having also the mechanical equations will be there. The torque equation with respect to that one, so electromechanical torque of a PMSM motor. So I already said in the before video itself, the assumptions like it's a two-phase PMSM motor. So torque equal to 1.5 into P by 2 into lambda M into IQ, where lambda M will be the flux linkage, as which is already there in the same equation also here also there. Okay, and IQ will be the Q axis current. So these two will be there. Now what I need to do is I need to convert the I discussed about electrical equations. Now I need to consider the mechanical dynamics also. So regarding that one, so as the in before itself, Newton's second law for rotation. Okay, so T equal to J, that means inertia with respect to d omega by dt, plus B, that means viscous friction, and with respect to the angular velocity. Okay, so that is that one. So here where G is the moment of inertia, B is the viscous friction, this connects the electromechanical torque towards the motor speed. This is very much important. So that's why I'm saying like it as it is having a towards the motor speed equation. That means now the torque is connected to the speed equation, which is an electrical component, mechanical component. It's a mixture of both. So now what we need to do is we need to apply the Laplace transform. Why? Because to get the transfer function, we must need to apply the Laplace transform to that one. So when we are applying the Laplace transform, what will happen is, as we already know, the initial conditions will be 0. Okay. So when we apply the Laplace transform to the IQ component, IQ of x minus equal to VQ of s minus W into lambda m by R plus SL. So it is a final equation of the IQ axis, and also the here whatever the before torque equation is, the torque equation into the, and also torque equation. Okay. As the video is getting lengthy because it is having a more equations are there, I'm just cutting down here because it is in the foundation stage of the equation, so it will be connected to the next equation, next video. Thank you.